Let's take a look at final exam question number 67, found on page 675 of Teach Yourself Electricity and Electronics, 5th edition. Engineers represent pure capacitive reactance values in mathematical terms as what? And then we're given some various options in regards to types of numbers that this particular quantity represents. Now, a pure capacitive reactance means that you have nothing but capacitance. An ideal capacitor would exhibit capacitive reactance at various alternating current frequencies. The capacitive reactance depends on the frequency. We symbolize capacitive reactance as X sub C, X meaning reactance, C meaning capacitive, but we always precede it with the J operator if we want to get really technical. And remember, the J operator is equal to the square root, actually the positive square root of -1. Well, that's not quite all of it. Capacitive reactances, this particular value here, X sub C, the real number coefficient, is always negative. When we multiply this J operator by a negative real number, we get a negative imaginary number. That is choice A, as in alpha. Now suppose, let's just go explain this just a little bit more, just to give you a little more insight as to how this works. Complex number impedances are represented on a half plane, coordinate plane, where we take resistance and plot it out along the horizontal axis going to the right. Resistance is always 0 or positive. We can have minus Jx, that is capacitive reactance, going downward along the imaginary number axis, plus Jx is inductive reactance, which goes upward. A pure capacitive reactance value will always appear as a point somewhere right along that negative vertical axis. We can also represent it as a vector going from the origin and pointing straight down. If we had resistance combined with capacitive reactance, we'd get a vector pointing off something like that. Pure resistance vectors with no reactance at all point right out along that axis. If we have a pure inductive reactance that points straight up, the vector representing it would point straight up. That would be like an ideal coil of wire at some alternating current frequency. And if we combine some inductive reactance with resistance, we get a vector that points upward and to the right like that. But again, the correct answer to this question is A. Engineers represent pure capacitive reactance values in mathematical terms as negative imaginary numbers.